to start because I know what the PowerPoint says, or at least some of it. Okay, well, tonight what we're going to do is we're going to be starting the physics section of the course. So that's going to happen after my remarks and Linda's remarks and you guys Q&A. Now I realize that yeah, I guess here's the outline. Okay, now the midterm for you guys, for the VCM folks, is going to happen in class, at least for almost all of you. It's going to happen in class next week. That's 1 week from tonight. And so you want to come prepared and ready to go, and things like that at at 6 o'clock, so you have the full amount of time to do it. Now next week, or not next week, next time we meet, Linda and I are going to discuss in detail what you need to do to have ready. And this is going to, and we'll do a little bit of preparation before Linda leaves next time. We're going to, okay, Linda's taking a break right now. But let's see. So we will practice. In fact, we'll do some practicing on that protocol next time. And basically what it's going to require you to do is and we'll send some emails so you can prepare in advance of this, but you want to make sure that you have Zoom downloaded on your cell phone, and you need to think about where you're going to put your cell phone so you can be watched while we're proctoring the exam on the 18th, and we'll practice that a little bit. Now, on one hand, I'm not as concerned about people cheating in this class, just because we basically give you everything, to start with. So it's mostly checking to make sure there's not people there helping you with the exam and things like that. But you're pretty much going to want to be on target, because like I made of the exam, and then Linda had some suggestions about additional questions she thought were good to ask, and I agree with her, but the net effect of that makes the exam longer. So it is important that you'll be on task and ready to go. So we're going to have some serious practice about that the next time we meet, which is going to be on the 20th. So on the evening of the 20th, and before that, you VCMers are going to receive some information about what you should download and how you should come prepared. And then we'll do a little bit of practicing so that you're ready to do that. And also I will have at that meeting as well, there'll be a complete list of the grace notes so you can see everything that you need to have. So anyway, so the midterm is going to happen for this class on the 18th, and we're going to have and the net class is going to have the same amount of time, although they have to be administered differently. So that's what I'm doing with them. And in addition to showing the grace notes, there'll be the final topical outline, just of saying things, but it's going to be very much what you expect. There'll be a regression problem with multiple parts. There will be a confidence interval problem, and so on and so forth. So we're going to do most of the statistics that we do. We'll have descriptive statistics, all of that. So anyway, what we're going to do then is we're going to be doing physics tonight. I did send you, now this was just moments ago, might have been an hour ago or so, but I sent you 3 videos to look at to get you started, and I think those videos are useful. But tonight we're going to do some drilling on some of those concepts, and I understand if you didn't get to see the video yet, but I would encourage you to go back and watch them in the wake of this, and we're going to go over and actually do some problems and other discussions about the physics tonight here. And the discussion we're having tonight will come from chapter 1 in the physics book. And so pretty much we do a chapter a week, just like we did in the statistics, and that'll bring us to the end. And the final exam in this course, the midterm is going to be all statistics, and the final exam is going to be all physics. And so that's how that will fit together. Okay, Now, I did come to this point where I said Linda with question marks, but I think she's caring for something on her end, and so I doubt if she's here. And so what I'm going to do is I'm going to throw it open for student Q&A, and then perhaps by the time we're finished with that, Linda will be back, and we can hear from her, and then we can move on. So I'm throwing it open for student Q&A now, and I'm going to count to 10 Mississippi to give people a chance to raise their questions. Okay, when will you post the grace notes and the study guide? Well, I would hope maybe tomorrow, but and I think that was someone named Mary Kate, but anyway, it doesn't matter who it was. Um, so I will do it, but I have to go back and include Linda's suggestions in the final, and then post them. So I would hope maybe tomorrow, but soon, before we meet again, I think for sure. How many LSAs should be turned in by the 18th? Let me go and consult on that, and I'll give you an answer for that one as well. I think it's all the ones that we have, and I just have to count to tell you how many there are. So I will owe you that, as well as the study guide and and showing you what the grace notes are going to be. Now you actually have a pretty good idea of what the grace notes are going to be, because I'm just cutting out the ends of the chapters, from the statistics book, and so you've seen pieces of that before, but you can see it all together at once. So probably before we meet again, and who knows, maybe tomorrow. I would hope maybe tomorrow. Okay, other questions? Okay, I hit 10 Mississippi, so your questions are always welcome. Oh, one student did ask a question in email, and he said that this student who was writing in said, well, gee, yes, there are office hours this week, and I do have office hours. Tomorrow I will not have office hours because the College of DuPage doesn't have office hours. I mean, that's the College of DuPage decision, not my decision. But tomorrow there won't be office hours, but ordinarily there will be office hours. Okay. And in fact, that kind of was the nature of the student's question. It said, gee, I really think I could use some, discussion on things. And Linda responded to this, and she said, well, she has these hours every week, and I have these hours every week. And so the first thing is to check to see, well, can that work? Now, sometimes it perhaps can't, but that's the first thing that we would try, because that's when we were scheduled to do this. But we do make arrangements to accommodate people, and I, for example, was working with a student on the phone yesterday, as well as this morning in office hours. So we do that, and we do try to accommodate people's needs. Okay, let's I'm going to count again. Okay, so we hit 10 Mississippi, so I think I'm going to ask if Linda's there and she has anything to say, and if she's not back yet, then we'll just go ahead. So Linda, are you back yet or no? And she is not, so maybe 7 is taking her time. Anyway, here we go. Okay, now I just pulled a few things from the chapter 1, and I may have talked about some of these things, but this is kind of an interesting thing, because bats actually send off signals that are extremely high frequency bursts of sound, and they use that to and they don't have mathematical equations, so they just natively know how to use that sound to locate their prey. And that's pretty much what you're doing with ultrasound. Is you're using sonic waves, high frequency waves, to take an image of what's inside someone's body. And so it's not just people that do this, but whales use ultrasound, and in fact bats use ultrasound as well, high frequencies, to locate their prey. So that was an example of that. One of the things that's going to be different with physics is that we're going to be very concerned with units. And so when we measure a physical quantity, we always have some reference, and that really has to do with a unit. So for example, if we say a rope is 30 meters long, that means it's 30 times as long as a meter stick. And so you see these units matter. So we will talk about not just the length of the rope is 30, but it's 30 meters long, and that's different than being 30 centimeters long or something like that. Okay, now units come in basically 3 dimensions that we want to talk about. There is a time dimension, and we usually use seconds there. There's a length dimension that we use, and we use meters and centimeters and millimeters and so on and so forth when we're in the SI system. In the English system, we use feet and miles, which are more inconvenient and not as standard, but we do use those. So time, length, and then there's mass. And mass is kind of how massive, not to abuse the word, but how much mass is there. And so like I am much more massive than any of you young women are because I am very plump. And so, I have a lot of mass. So anyway, we will talk about time, length, and mass, and we will see very soon that mass is different than weight. And so we're going to be talking about units, and units matter. So there we go with that. And the video I ask you to watch goes and talks about many of these powers of 10. In fact, they go out into space to 10 to the 24th meter, which is the limit of the known universe, and they go down to look at things that are basically nanometers. And so a lot of this stuff is talked about in that video, but these are powers of 10, and that's 10 raised to these powers. Now, when you say 10 raised to the 18th power, that means if you talk about that number, you will have 18 zeros on the end of it. 10 to the 15th will have 15 zeros. 10 to the 9th will have 9 zeros, and so on and so forth. And what happens is if you have 10 to the minus 2, that will be 2 places after the decimal point. 10 to the minus 3 will be 3 places after the decimal point, and so on. So you can see there's a lot of range that happens here between things that are very big, 10 to the 18th, and things that are very small, 10 to the minus 18th. And sometimes they use abbreviations to talk about that. Like, for example, sometimes they will use the symbol N, and they will use the word nano to refer to 10 to the minus 9. Micro is use the symbol mu. That doesn't mean mean anymore. That means just that's the symbol for micro, and millimeter, and so on. So sometimes in the physics problems they'll use these abbreviations. Sometimes they'll use the words, and sometimes they'll use the powers of 10. So you have to get familiar with these as you work on them, because that's going to matter, because these will come up in the middle of problems that we'll be working on. So the powers of 10 is an important thing, and the powers of 10 video that I ask you to watch is actually a good introduction to this topic. And pretty much it talked about this. They went out in the video to 10 to the 24th, and here it talks about 10 to the 26th, and then they went down to, actually, they went down to, I think, maybe it was 10 to the minus 12. But anyway, the video actually shows you pictures and talks a lot about this wide range of sizes. And you actually will talk about a wide range in ultrasound as well, because you're not going to be talking about very long lengths, but you are going to be talking about very high frequencies. So you're going to be talking about megahertz in frequencies. So there really will be a lot of these powers of 10, so you want to make sure that you're comfortable dealing with it, and you also should expect to deal with these things. Okay, let's go to the next slide. And this just talks about some of the examples of length, but it does talk about what these are, okay? So for example, a nanometer is a few times the size of an atom, so it's not very big at all. A micrometer or micrometer is the size of some bacteria. A millimeter is the size of a point on a ballpoint pen, and a centimeter is the diameter of your little finger, and so on. Mass, if we talked about a gram, that's how much a paperweight. If you lift it up, that's how much mass is associated with a paperweight. And a kilogram is the mass of a 1 liter bottle of water. And times, you know about times, but some of these conversion factors, turning time into days and stuff, we're going to be doing some conversions of these units as well. So units matter, and we'll be spending a lot of time doing things with units. And this is a famous screw up. The last time we went to Mars, not the recent expedition, which has been wildly successful, but the one prior to that was kind of a disaster, because there was a confusion about the units and the thing crashed and burned, and that was millions upon millions of dollars that was wasted because of that error. So that can be very costly. One thing that happens is there are rules about significant digits, and that tells you how you should round off. I'm not going to be a stickler on this, but sometimes you might check the answer in the book, say, oh, I thought I did that right, and they show a slightly different answer. That's because they're rounding off differently. And where it matters, I will give you guidance about rounding off. But the general thing is, don't round off till the end of your problem, and then I'll give you guidance about how to round things off. Okay, and now we're about ready to begin talking about something. You might say, trigonometry, why are we talking about that? Well, this is going to be important about vectors, okay? And Linda, are you back yet?
Yes, I am.
Excellent. And how's Seven? Doing okay?
Hopefully. She's been kind of sick the last couple days, so I'm hoping that she
Oh,
won't need out again, but we'll see.
well, I hope she is okay. Just keep us apprised. Okay, now what we're going to do is we're going to do some problems dealing with units, and we're going to do some problems dealing with this. Now, Linda and I will review all of this trigonometry, and Linda and I also will do shortcuts to enable you to do the calculations. But trigonometry is involved, and basically all you need to know in this course is right triangle trigonometry. But that's the triangle that has a right angle, and you have opposite sides, adjacent sides, and things called a hypotenuse, and we have sines, cosines, and tangents, and we have a little bit of trig identities. But we're going to be talking about that later, and Linda and I are telling you everything you need to know. You don't need to have studied this before, you just need to pay attention and tune in this time through. So that's another coming attraction tonight. And we will be doing component additions and subtractions, and so we're not going to spend time on this right now in the abstract. We're going to go back and actually do this in the context of solving some problems. Okay. All right, so let's just get started. And I think what we're going to do is talk about a few of these things, and we want to maybe change, do some changes of some of these units and things like that. So I am going to suggest that we just dive into number 2 here, and this is dealing with biology, and a lot of times I pick biology problems because I think you guys should be interested in biology problems, and it looks like there is A, B, C, D is there. So they're asking us to express things. And Linda, could you copy that and stick that on an Excel spreadsheet for us? Or actually, that's probably a good thing to do. So she's going to put that on an Excel spreadsheet, but I'm going to begin talking about this, and so we're going to be able to talk about this. So the recommended daily allowance, and that's RDA, of magnesium. Magnesium is supposed to be good for you, I think, is 410 milligrams per day. And you want this in micrograms per day. So Linda's going to put that into the Excel, but I'm going to go and share my screen with you to start with. And so I'm going to, let's see, actually Linda's sharing the screen, so I need to think about how do I share. Oh, I know how I share, hold on. It's down here. Okay, so I'm going to share, and I'm going to share a blank whiteboard. Okay, so this was 410 milligrams a day, but you wanted that to be micrograms. Okay, so this is going to be, and I will grab my pencil, and I'll use the pencil, and so this is going to be, and I need to tell it I'm using a pencil, and I have to go get the color of the pencil, I think. Maybe I don't have to do that, but it's not coming up with the pencil yet, so I'm not sure where I get the color here. Let me see if I can draw anyway. So it's 410, nope. So maybe I'll try something different. Maybe I'll try the brush. And it still doesn't have a color wheel. Maybe it's here, nope.
So once you've selected the brush, then
Yeah.
there should be like a little paintbrush that you can click on, and that'll let you pick the color.
Okay, but that didn't happen when I did this. So mine's not working that way. Oh, is this the paintbrush? I don't know that I don't know if I got that or not. The last time I was doing this, I would get colors and everything else. Okay, it looks like maybe I can now use at least the pencil though. Okay, so this is 410, and that was, I think it was milligrams. Okay, so that 410 milligrams per day. And what I want to do is I want to change this into, and this isn't working well at all. Okay, milligrams per day, and I'm going to multiply this by, and now I want to change this into micrograms. So I want the micrograms to cancel, or the milligrams to cancel. And so I know that there are 1,000 micrograms. I'm going to erase all this because it's coming off so crappy. Okay, so I'm erasing all this, and I'm going to see if the text thing will work better. And I hope that it will. Okay, now I have the eraser again. There. Okay, so that's good. Okay, so now I'm going to try to use the text tool and see how this works. Okay, so then I had 410 So I have 410. Okay, and this is mg per day. Now I want to change this to, so I'm going to be multiplying this times, and then I need to have a conversion factor, and at the end I want to have micrograms per day. So what I want to do is I want to multiply this by a conversion factor, and so I want the micrograms to cancel, so that's in the denominator, and this is going to be times, this is going to be 1 microgram divided by, and that is, in fact, this really should be times, there are 1,000 micrograms per, and underneath this I'm going to have, and I can't do that with the text, so I have to go back and redo the text field, but I come over here, and this is going to be micrograms per, and this is going to be 1 milligram. And so if I do that, I'm going to get 410,000 micrograms. Okay, so the answer to this problem then would be 410,000 micrograms. 410,000, and this is micrograms. Okay, and that is the same thing as, that is going to be 4.1 times 10 to the, and I move the decimal point 1, 2, 3, 4, 5 places, times 10 raised to the 5th. And a lot of times I use this just because this is Excel kind of language, and that's times 10 to the 5th. Questions about this example? Okay, Linda, did you copy that into an Excel kind of thing?
I did.
Okay, let's change to you then.
Okay.
Let's lose this whiteboard of mine, and she's going to show you a problem. We're going to pick another one, and she's going to talk through this with the with Excel. Okay, so we're looking at this another one, and okay, a typical. I'm reading problem C. Or wait, let's do it this way. For adults, the RDA of the amino acid lysine is 12 milligrams per kilogram of body weight. And again, they really shouldn't say weight, but they do that anyway, body mass. How many grams per day should a 75 kilogram adult receive? Okay, so Linda, why don't you go with this, please?
Okay. So they tell us right off the bat that it's 12 milligrams per 1 kilogram. So I'm going to start by writing that out. And I'm putting the units next to it just so we can kind of keep track of how things cancel. It should be milligrams. And then they're asking how many grams per day for a 75 kilogram adult. So first thing I'm going to do is multiply this by the 75 kilograms to cancel that unit. So you can see with that kilograms in the denominator and kilograms in the numerator, that'll cancel. So once I multiply this, I'm going to be left with milligrams. Now they're asking how many grams per day. So I need to change milligrams into grams. So I need milligrams on the bottom to cancel with the milligrams on top over here. So there are 1,000 milligrams for every 1 gram. So once these cancel, I'll make those orange. Then I can just multiply everything straight across. So in this case, I'm doing the 12 times the 75 in the numerator. And then in the denominator, then I'm just going to end up with that 1,000. So then I divide these since it is a fraction. And I end up with 0.9 grams, since that is the only unit that didn't cancel.
Questions? Are we good with this? Let's do one more of these, Linda, and you can pick which one you think you would like to do.
Okay. Let's see. I guess we'll do D. So they're saying that the RDA for the trace element selenium is 0.000070 grams per day. So I'm going to write out that number. And then again, I'm going to attach my units. So that is grams per 1 day. And they want this in milligrams per day. So my day unit is all good. I just need to change grams into milligrams. So if my grams is on top over here, then I need grams on the bottom over here. And again, I know that there's 1,000 milligrams for every 1 gram. So all I'm doing is just multiplying these. Because in my denominator, then all I have are ones, so there's nothing really to simplify there. So I end up with 0.07 grams per day.
Questions? Again, doing these kind of conversion, yeah. Doing these kind of conversions are things that you want to be good at, and things like that. Let's do something a little bit more complicated. And Linda, let's maybe go into you're going to need some Excel real estate anyway, and I don't know if you want to delete those words or what you want to do, but we're going to do the furlongs per fortnight kind of thing. Okay, now to do the furlongs per fortnight kind of problem, I'm going to tell Linda some facts, okay? And one thing I'm telling Linda is that 1 mile is 8 furlongs. Okay, so that's one thing that we need to know. And the other thing I'm going to tell Linda is that 1 fortnight is equal to 14 days. Okay, now you see, so furlongs per fortnight is actually a measure of distance per time, and that is going to be speed. And if it has direction, it's going to be velocity. So this is really a speed. So I'm going to ask Linda to change, and she's going to go through a kind of an extended thing here because she'll need a lot of space. But she is going to say, suppose I'm in a car and I'm going 75 miles per hour. So 75 miles per hour. And I want to change that into furlongs per fortnight.
Okay. So first thing, I'm going to deal with the units in the numerator. So that's just changing the miles into furlongs. So we already know that 1 mile is 8 furlongs. So I'm going to write this so I have the 1 mile on the bottom. That way my mile units will cancel. And this is 8 furlongs. So I'm going to get rid of those mile units. Now you can see that I'm in furlongs per hour. Okay? Now to get hours into fortnights, first I need to get into days. So I know that there are 24 hours in one day. So I need to put hours on top. That way the hours units will cancel. And that is for one day. Everyone with me so far?
You're getting
Okay.
some positive response there, Linda, I think.
All right. So now that I have furlongs per day, then I need to change days into fortnights. Now we were told one fortnight is 14 days. So I need my days unit in the numerator. That way it'll cancel with the one I have in the denominator. So I'm going to have day per fortnight. And there are 14 days, we were told, for every one fortnight. So now my day units will cancel. I'll put those in blue. So the only units we have left are the furlongs and the fortnight. So from here, I can just multiply straight across. So I'm doing the 75 times 8 times 24 times 14. And that's going to give me my numerator. Now in my denominator, the only numbers I had are ones. So this would be 201,600 furlongs per fortnight.
Okay, so units matter, and you're going to have to do some unit problems. Now let's go, and we're going to do some vector things, probably for the balance of the period. Okay, so Linda, can we please go back to the PowerPoint show?
You got it. Let's see. That looks like a good one.
Yeah, I think this is a good one to have. Okay, now here are some things that I'm going to say you'll want to commit to memory. Now we will have these on grace notes when we get around to doing the final, but you don't want to have to look on the grace notes to get this. So here is what happens. If you have a right triangle, and the thing that makes something a right triangle is you have a 90-degree angle. And that symbol there that looks like a square means that that is the right angle. And then you have an angle over here that is called theta. And a triangle has three angles. So you have that right triangle thing, you have that theta thing that looks like a zero with an arrow through it, and then you also have one that's not labeled at all. Now the side that is opposite the 90-degree angle is called the hypotenuse. And I'm moving my cursor, and I don't know if, Linda, can you see my cursor or no? You cannot.
I cannot.
Okay, so I'm not sure if I want to even try to fix that. Okay, but anyway, the side opposite the 90-degree angle is the hypotenuse, and that is the longest side of the triangle. So what we will do is, and the reason this is true is because if you have a right triangle that has an angle whose measure is theta in degrees, then the other angle is determined because those two angles, you got this from your geometry that you studied, those other two angles have to add up to 90. So if you know one of them, the other one is 90 minus that. Okay, so what that gives you is that this right triangle completely determines the ratio of the sides. So we define the sine, and that is called sine, not sin. And it's spelled S-I-N-E, except it is the way you say that is sine of theta, is the ratio of the opposite side to the hypotenuse. So that is called the sine of theta. And that's something that you have in your calculator. And Linda will, when we do some problems, we'll do calculators with this. We also have one that's called the cosine. And the cosine is the ratio of the adjacent side to the hypotenuse. And the tangent is the tangent theta is equal to the ratio of the opposite side to the adjacent side. Now, you can prove that the tangent theta is the sine over the cosine, and you also can prove, and this really is the Pythagorean theorem, that if you take the sine squared of an angle plus the cosine squared of an angle, that's equal to 1. And you might be saying, well, Jim, do we really need to know that, or are you just telling us some mathematical nonsense? You really need to know that, okay? So what we're going to do is we're going to break vectors into their components, and we're going to solve those things using trigonometry. And so we're going to talk a bit about that. So I'm going to advance the slides then, and we're going to find a problem that we're going to do. And when I keep saying vector, a vector is something that has magnitude and direction. And so here is a problem that I like that's a vector problem, is this one shown as problem number 45. So you can see it now. Now don't worry about what these units are, but I will tell you that later on you're going to understand these units, and these are called newtons. And by the way, in this physics book, they didn't define this before then, or I would have defined it for you. But we will talk about what newtons are when we get to chapter 4. But anyway, a Newton is a unit of force. So you see what happens is you're taking horizontal ropes and we're attaching them to a boulder. And the boulder is at the point 0, 0. And this produces the pulls. So someone is pulling on this rope called A in a direction that's making an angle of 30 degrees with the x-axis. Someone else is pulling on a rope at 80 newtons that's making an angle of 30 degrees with the y-axis that you can see there. And there is a third person who's pulling at a rate of 40 newtons. They're the weakest of the three, and they're pulling at 53 degrees, which is the angle that that third one makes with the x-axis. Okay, now what we're going to do is, and we're more or less following these directions, but what we're going to do is we want to figure out what happens to this boulder. So you got three people pulling on it in different directions with different levels of strength. And so the question is, what happens to this boulder? And that's the vector sum of all these. So what we're going to do is we're going to do things called breaking the vector into its x and y components. Okay, so what I'm going to do then is I'm going to share, and we're going to work on this. And Linda, I'm going to say in the background, now maybe it's not so much in the background, but I would like for you to be, kind of keeping track of this in an Excel format when we add these together. But what I'm going to do is I'm going to take vector A, which is 100 at a 30-degree angle, and I am going to decompose this into its components. So I'm going to share with you a whiteboard, and maybe this will work out a little better than it did the last time I shared the whiteboard with you. Okay, so I'm sharing a whiteboard with you, and it is not blank, but it'll be blank soon because I'm going to erase that. Okay, so I have the eraser. And it's not letting me grab the eraser. There we go. Okay, well, we're not going to erase that, but what I am going to do is I'm going to go over here and maybe try to draw with this symbol. Okay, so I'm going to draw a line there. That did erase it finally. Okay, so I'm going to draw the angle that I have. This is the vector, and this is 100 long. And it's going at 30 degrees. So this is 100 newtons. And that is 100 newtons in that direction. And the angle was 30 degrees. So this angle was 30 degrees here. And to do this, I'm always going to drop the perpendicular to the x-axis. Now you might say, well, in high school I didn't always do that. No, but Linda and I are trying to teach one thing here. And so you always drop the perpendicular to the x-axis to figure out the components. So this is going to be, and we call this vector A. So since this is vector A, and I'm going to call it capital A, then we're going to have a vector called AX that we're going to put here. And this, or rather AY. So this is capital A, Y. That is the component of the vector A that is in the Y direction. And down here, we're going to have the component of vector A that is in the X direction. So this is going to be A in the X direction. This angle that we have right here is 30 degrees. And we know that's 30 degrees because of the problem. So this is going to be 30 degrees. Try that a little bit higher. So that's going to be 30 degrees. Okay, so now what I know is that AY divided by 100 is 30, is the sine of 30 degrees. Okay, so let me write this. So this is sine, I'm putting parentheses around this, 30 degrees is equal to, this is going to be AY divided by, and I'm just going to put a slash there, and this is going to be 100. And I'm also going to know that the cosine, which is the adjacent over the hypotenuse, so the cosine of 30 degrees is going to be equal to AX divided by 100. Now, Linda, could you show the students where we're going to get the sine of 30 and the cosine of 30 from their calculators and how we're going to solve for A, Y, and AX?
Yeah, absolutely. So let me share my screen real quick. And then to compute these, all I'm going to do is just search for a calculator. So there should be a calculator app on almost everyone's laptop or desktop or whatever you're using. Let's see. I need to type in the angle first. So in this case, we have 30 degrees. And I am in degrees, not radians, so I should be good to go. Then I'm going to take the sine of that 30, and then I need to multiply that by the 100. So that'll give me 50 for my a sub y. Everyone okay with that? Ah, easy, they say. Fantastic. All right, so then if I want to compute my a sub x, then I'm going to do roughly the same thing except with cosine. So I type in 30 again. I can go under trigonometry and pick the cosine button, and then again multiply it by 100 to get your a sub x. So in this case, we're just going to round it to 86.6. And then if I open my Excel document, then I've been keeping track of all these different formulas. So this we'll just call 86.6, and over here this was 50.
Okay, and now I'm going to share my whiteboard again with you. And we're here, but now we need to do B. And maybe you remember B, but B was like this, going off in that direction. And the y-axis was like this, going down. And this angle here was 30. So this was a 30-degree angle, but it was with respect to the y. Now, I always told you that we drop the perpendicular to the x-axis. So I'm drawing the x-axis along here like that. Hopefully I can pick it up and move it. I can, that works well. Okay, so I have that. Now, if this is 30 degrees here, then the other angle, when I drop the perpendicular to the x-axis, this angle that is in the triangle is going to be 60 degrees. And I typed 30, I meant to type 60. Okay, so now I've typed 60. But now it's important for you to realize that this is a plus going up here. This is going to be plus, but the x is going to be minus. And so this is a positive. This side is a positive, but this side down here is going to be a negative, and I think I have to do that again. And the reason that is a plus and a minus is that that's the way the x and y axis works. If you go up on the y axis, it is positive, and if you go down on the y axis, it is negative. If you go left on the x axis, it is negative. If you go right on the x axis, it is positive. Okay, so Linda, and it sounds like is 7 okay, or is she?
Yeah, no, she's fine. I just still had my mic on and she's chewing on a bone in the background.
Okay. All right. Okay. So you want to run with this again, or you want me to do it?
No, I can do it as long as they don't mind some background noise.
I actually enjoy the background noise. So
Okay.
go
Let me
ahead.
share my screen again. So on my Excel document here, then I did make it so the minus and the plus are kind of notated, so we know that's supposed to be a negative for the b sub x. Now, to get those numbers, I'm just going to type that into my calculator again. So I'm going to clear this out, and now I'm doing the cosine of 60, so I need to type in the 60 first. Then I can do the cosine. and then multiply it by 80. So for that one, I'm going to get 40. For the b sub y, then I'm going to clear this, type in my angle. So that was 60 again. Now I'm going to take the sine of it by going under the trigonometry and then multiply that by 80. So it's important to remember, though, that is a negative 40 that we got for the b sub x. And then for the b sub y, it is going to be that positive 69.3 all around that, too.
Okay, now we're going to go back to, let's pause there. Is everybody okay with what Linda did there? Apparently so.
Okay.
So now I'm going to go back and I'm going to share the whiteboard again because we had a third one. And the whiteboard is going to be up here. And you see we had A and we had B, but we also had a C. And C looked like this. And I'm going to draw my X and Y axis again, just for reference. And I guess I need to do that again. But C was going down here at 53 degrees. And so I always drop the perpendicular to the x-axis in this class. So I'm dropping the perpendicular here. But this angle here is 53 now. And so you notice that you have to pay attention so you know what the angle really is. But this is 53, not 63. Okay, 53. There's the 5 and the 3. Okay, that's good. So that one is 53. So we're going to be using 53 as our angle, but I think it's important for us to note that this time the x is negative and the y is also negative. So both of these are going to be negative this time. Okay. And Linda, take it away then, please.
All right. Then let's see. So going back to Excel real quick, then I did notate those minuses on each of these so we don't forget. And then these are the formulas that we're going to be typing into the calculator. So again, start with the angle. So we have 53. I'm going to do the cosine of that and then multiply it by 40. So I end up with basically 24.1, we'll go with. And that is a negative 24.1, right? Because it is going in the left direction. Hold on. There we go. So then next, I'm going to do the exact same thing, but for sine. So again, start with the angle, or trigonometry. We're going to click on sine, and then multiply this by 40. So we do end up with a positive 31.9, but it should be negative because the vector was going down. So that's going to be a negative 31.9 over here.
And Linda, someone did ask in a chat about the negative, and I know you addressed that in part with your comments right there, but could you address it a little bit more explicitly again, why they're both negative?
Yeah, so if you remember back in like algebra when they first had you plotting points and things, then the positive x values were on the right side of the y-axis, the negative x values were on the left-hand side. And then same kind of deal with the y-axis, where the positive numbers go up, the negative numbers go down. So in this case, if we're looking at vector c here, it's going to the left and down. So that means my x is going to be negative and my y will also be negative since it's going down.
Okay, Now, here's what's going to happen, all right? We're going to, and Linda's going to do this with Excel. She's going to add all of these, the A component in the X direction, the B component in the X direction, and the C component in the X direction. And we call this the resultant, and that is R. And so R in the X direction, the total is when she adds all those together. And R in the Y direction is the total when she adds all the Y's together. Now she is adding some things that are negative and some things that are positive, so that's what we get. But now let's go back then to the, I'm going back to the whiteboard again. Okay, so you got all these. The A is up here in the upper left-hand corner. The B was in the upper right-hand corner, and the C was down here kind of in the middle. But now here is what we have. We now have added those together, and so we have an R in the X direction. And what did you have, Linda, for that one? The R in the X direction.
Let's see. That was 22.5.
Okay, so this is 22.5. That is the R in the X direction. But then there's the R in the Y direction. And Linda, that was a way bigger number.
87.4.
Okay, so I made it look kind of like 87.4 here. But you see, now I'm reversing my thing. Before, we were breaking the hypotenuse into its X and Y perpendicular parts. But now we have the perpendicular parts. So what we're going to be doing is we're going to be reversing this with the Pythagorean theorem, and we're going to find out what is R, and then we're also going to find out what's the direction of R. So what's going to happen is that R squared is equal to R sub X squared plus R sub Y squared. That is the Pythagorean theorem. Then we're going to take the square root. Okay, so just to write that, and it's not going to be a great writing, but I'll write it here anyway. So we can say that R whole squared, and I'm going to do the squared like this, okay? And that was not good. Okay, so this is capital R, and this is squared is equal to, and this is going to be R sub X whole squared plus this is going to be R sub Y squared again. Okay, and then we're going to solve that, and that will give us the length of R, and then we're going to talk about how to find the angle theta. Okay, so Linda, can you take this over and find out what R squared is and then what R is?
Yep, I actually already did it.
Okay, good.
So
Just
if we
talk people
jump to
through that.
Excel, then I have my components right here. Then I squared each of them. I added those together, and then I took the square root, so we end up with R being about 90.2.
Okay, 90.2. And now what we're going to do is we're going to talk about the angle that this is going off against. Now, 90.2 then is going off, and you can see the way we drew those with both of those being positive. That's going to be in the first quadrant there, but we need to find the angle. So let's go back to the whiteboard. And so I will share the whiteboard with you one more time. And we're here, but you see, this is the angle that we want to find right here. I'm going to call it, I'm just going to call it angle. Ah, damn. I have to start having lights on in here, I think. Okay, so this is going to be A-N-G-A-N-G-L-E. L-E. Okay, so that's the angle we're going to do, but you can see that the tangent of the angle is going to be, so the tangent of the angle is equal to, okay, and this is going to be Ry over Rx. Slash Rx. Okay, so now that we have that, we can find the angle by using what's known as the inverse trig functions, and Linda will talk about that. Okay, and she has the numbers for Rx and Ry. Go ahead, Linda.
Okay. So I'm going to go back to Excel real quick. So first thing I need to do is figure out what Ry over Rx actually is. So I'm going to take these two numbers, that was 87.4, and divide that by 22.5. So that is my thing that I'm taking the inverse tangent of. Now, if I look under trig, I do not have an inverse tangent here. So I need to find my second button, and then that'll give me, there we go, a whole bunch of different options. So this is my inverse tangent button, and when I hit that, I get 75.6. So that would be the angle, and it is in degrees since that is the mode that my calculator is in.
Okay, so going back to the whiteboard then, what that means is that if we were to have all of these, actually, I want this one, not that one. Cancel that, share this. Okay, so if we had all three of those vectors, A pulling out this way, B pulling this way, and C pulling this way with those various magnitudes, the net of all that would be a force of 90 newtons and change going off at 75 degrees and change. Okay, questions about any of this stuff? Because I think this was a pretty typical vector problem. Linda, that must have been a really good job you did explaining this, so that's good. Okay, let's go back to the slideshow. And I do know what time it is. We got about 5 minutes, or maybe a little short of that. But we're going to go back to the slideshow then, Linda, please. Oh, wait, do I need to do that, or can you do it? Yeah, she's doing
I was
it.
working on it. I was just trying to find the right slide.
Okay, that's good. Okay, so you see, that's what we really did. So we used the trig functions going one way to find the components, but then going back, we had to use the Pythagorean theorem and so on and so forth. Now we're going to look at another problem. And this next problem that we're going to look at is one that I have asked on. And by the way, I think I'm going to assign this problem here with this brass washer. I'm going to assign that as an LSA for you. It's not due before the 18th, and it doesn't count before the midterm. It's after the midterm is when that's going to happen. But I'm going to here. That was a vector problem we just did. But here's another vector problem that I did do. And Linda, we might even have time to do this. So I'm reading number 35. Okay, dislocated shoulder. A patient with a dislocated shoulder is put in a traction apparatus as shown in the figure. This actually was a test problem I gave once. The poles which is vector A going up that way, and vector B are equal in magnitude. That means they're each the same size. Otherwise, it would be screwing up his arm, I think, or her arm. I can't tell if it's a guy or a girl. It doesn't matter. So they have equal magnitude, but they must combine to produce a outward traction force of 5.60 newtons on the patient's arm. How large should each of these be? Linda, would you want to try to just talk through this briefly? And you got about 3 minutes.
7 actually just threw up, so I'm gonna go take care of that.
Oh, wait, okay. So,
I'll
someone
give
asked,
a poll on Wednesday for when we're gonna hold the extra guided study group this weekend, so I will talk to you guys about that later.
okay, why don't you go care for your puppy?
Yeah,
Okay.
sounds good.
Okay, I'm just going to talk about this a little bit while it's here, and I'm not sure that I can write on this, but I'm going to try and see if I can write on this. Okay, so you see the contribution that A is going to make here is the same as the contribution of B, and we want it to be a total of 5.6, so each of those is doing 2.8 going this way. So that means that I have 2.8 going this way. And after I have 2.8 going this way, I have this going up this way, and that is A. Now notice that A is the hypotenuse, and that's at 32 degrees. Okay, so that's at 32 degrees. So that means we know that the cosine of 32 degrees is equal to, and the cosine is the adjacent, and this is 2.8 over whatever the magnitude of A is. And so the magnitude of A then is going to be 2.8 divided by the cosine of 32. So this is 2.8 divided by the cosine of 32. And you could use the calculator to figure out what the cosine of 32 is, and you could have solved the problem. So that's actually looking maybe way ahead, but that is the kind of medical problem that I have asked that deals with vectors. And so A would be this number, and B would be the other number. Okay, so chapter 1's pretty much finished. We did some vector problems, things like that. Next time when we get together, we will talk about that. And before that, we will send you some things for you to look at, but we're going to come and we're going to make sure everybody is prepared to do that. Well, I have office hours tonight, and we have office hours then. I'm going to be sharing the study guide before the meeting, and I don't think that's really too late because that's the 20th, and that's not the 20th. The next time we meet is the 13th, okay? And so that means that's 5 days that you have to prepare. So I do think that that is time to prepare because I doubt if you prepare, more than a week in advance for the exam. Actually, I hope you have been preparing all along, but there will be time for that. So that'll all work out just fine. Okay, I guess it really is time for us to close. So I'm going to shut down this recording and we will go from there. You guys take care and good night.
Thank you, Professor. Have a good night.
Take care. Let's see, stop recording.